Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will do a problem from the homework set. This is from section 5.2. This is problem number 1. Here we have a random number generator that picks a number from 1 to 50 in a uniform manner. And we're assuming this is continuous, so we can also pick numbers that are between two integers like 19.7 and 48.23, etc. So they're asking us questions about this uniform distribution. A few things to get started. We have some information about the uniform distribution. Just for the sake of the notation, we have a special notation that we use for the uniform distribution, and we also have a function that's associated with it. There are also formulas that are an important part of the uniform distribution where we can find the mean and the standard deviation. So let's try some applying some of these formulas. Let's start with it's not asking for the notation, but let's come up with it anyway. So x is going to be, or this is the symbol that they use. This distribution is going to be uniform distribution, and it's going to take in your A and your B values. Your A value is 19, and your B value, your highest number, is 50. Okay, and our density function will be f of x is equal to 1 over 50 minus 19. I believe that's 31. So that's what we have for our function. So now let's get to actually doing the problems. The first two questions are to find the mean and standard deviation. So we can do that with 50. Be good to have a small little calculator nearby to do some basic computations. Our mu, in this case, will be A, which is 19, plus B, which is 50, and then we're going to divide it by 2. So this is going to be 69 over 2, or I believe that's 30. I believe that's 34.5. So that is our mean, and our standard deviation will be using this formula. Sigma will be equal to the square root of the difference between them, 50 minus 19, and then we're going to quantity square it, divided by 12. And so the difference was 31. And then we're going to square that divided by 12. And so 31 squared divided by 12. And then it's 80.833, but I'm going to go ahead and take the square root of that. And I'm going to get 8.94892. And we're going to want these to be rounded off to 4 decimal places, so I think we're going to stick with the 9. So here we have the first two solutions, or first two answers. We got a 34.5 and an 8.9489. So those are our first two problems. Now we're looking for probabilities that are exactly or between numbers. If you have a continuous distribution, whether it's uniform or normal or whatever other continuous distributions you run into, if they're looking for the probability that you get x is exactly a particular value, that will not have any areas. Remember, for continuous distributions, the probabilities will refer to areas, and this will not have an area. So whenever you're asked to find when a continuous probability distribution, what the probability is that you're going to get exactly one number, it's always going to be 0. In part D, now you're looking at some numbers between 29 and 35. So for this, it would be good to have a graph of your distribution. Remember, your function is just a constant function, 1 over 31. So 1 over 31, some value that's less than 0.05, would look something like this between 19 and 50. And now you're asked to find the area or the probability of getting a number between 29 and 37. So for this problem, you would think about looking at where 29 is, somewhere over here, and going all the way up to 37, so a little bit over here. And you're essentially looking for this area. All right, so you need to take the difference between 37 and 29, and that difference is going to be 8. So the base of this rectangular region that we're shading here is just going to be 8, and then the height is going to be 1 over 31. So the area, which is equivalent to the probability that we're looking for, is going to be the base times the height of this rectangle, of this area that we shaded. So 8 divided by 31 is about 0.28 or 25806, and I think we're going to round off to 81. After we clear this up a little bit, 25806. So that will give us a value, rounding off and making this into a 1, 0.2581. All right. Okay, the next question is asking us to find the probability, and maybe we can label this is question D, and then now let's go to question E. Find the probability that x is going to be larger than 30. So question E, we're looking for the probability that x is bigger than 30. And so I'll mark my 30 over here, and then anything bigger than that is what we want. And so this will have a base of 20 and a height of 1 over 31 again. So this area is going to be the base times the height, and 20 divided by 31 will equal to 0.64516. And so rounding off to the 4 decimal places, it's going to be 6452. 0.6452, and that's our problem number E. Now F, they want the probability that x is bigger than 31 given that x is less than 49. So this looks like it is going to involve a conditional probability. Let's write that down again. We're looking for the probability that x is bigger than 31 given that x is less than 49. So what we want to do is we want to look at a new denominator, a new basis for a denominator, and x is less than 49. So given this business over here, let's do a highlighter color for that. So given this is going to be my new sample space, so to speak. And that part here, where you get probability that x is less than 49, is going to be your new denominator. By the way, this is, yeah, so this is going to be your new denominator. So we can figure that out. This is 19 minus 49, that's 30. And then we have 30 divided by 31. So let's make that clear here. The base is 49 minus 19, and then the height is 1 over 31. So this is 30 divided by 31, which is 0.9677, 0.9677. And when we're doing intermediate steps, we want to round off to more decimal places. And then we'll do our computation so that when we finally get our answer, our answer is going to be good to the actual 4 decimal places. Because if you start rounding off to less than 4 decimal places, then you could lose some spaces. All right, so now from here, we want our x values to be bigger than 31. So we want our x values to be bigger than 31, so we only go up to here and up to 49. So 31 up to 49. So let's find this area over here. So this is the probability that x is going to be bigger than 31 and also at the same time being less than 49. So we only go up to 49, we don't go up to 50. So the base of this rectangle will be 49 minus 31, and that's going to give us 18. So the base is going to be 18, and the height is always 1 over 31. So 18 divided by 31 is about 0.580645. And so now to get this value, I want to divide these two numbers. And so this is going to go in the numerator, and then the number that we just got, 0.580645, and then we're going to divide that by 0.967749, and we will get about a 0.600, a bunch of zeros that eventually get to a 2, but rounding off to 4 decimal places looks like it's just going to be 0.6. All right, so that's the value that we will put in, 0.6. Okay, next, 29th percentile. So this was E, this was F, and then now we're going to do G. And I think it might be good to just have another copy of this. And we're looking at the 29th percentile. So what we want to do is we want to shade in a value. So this is what we're looking for. We're looking for a value here, x, we don't know. We don't know what x is. So that the area here is going to be 29%, or 0.29. Remember, the area of the whole thing is 1, but we're looking for this area, A equals 0.29, 29th percentile. Okay, so let's work backwards. We know that the area is base times height. A is equal to base, which is going to be whatever this x value, unknown right now, minus 19. And then the height is 1 over 31. So put that together, it'll be equal to this. And then we want this to equal to 0.29. So we'll do some algebra. It looks like we're solving for x in this equation. We'll bring the 31 over to the other side and we'll add a 19. So x is equal to 0.29 times 31, and then we'll add 19 to it, and then whatever that value is. So that's 0.29 times 31 plus 19 is 27.99. So 27.99 will give us that value. All right, so we'll go ahead and put 27.99, and then finally find the minimum upper quartile. So using the same box over here, the minimum upper quartile, if we break this up into half and then to half again, the upper quartile would be here, this value here. Let's call this one B, or let's call this one Q3 because that's what the quartile is, the upper quartile. So we can find this area here, which is going to be 25%, or we can find the area to the left of that, which is going to be 75%. So it's basically the same kind of deal. Where we're going to find the area. So let's focus on this area. The area is going to be 75%. It's going to be Q3 minus the minimum base here, which is 19, divided by 31, or multiplied by 1 over 31, which is the same thing. And then we're going to want this to equal to 75%. So we'll do the same work. Q3 will equal to 0.75 times 31, and then we'll add 19 to it. So 0.75 times 31, add 19, and then we're going to get 42.25. And if we look at this value, this is definitely between 40 and 50, and it does make sense. So also the 27.99 makes sense according to our number line as well. So 42.25 is our last answer. 42.25, and that should complete it. Okay, this problem is kind of like an overhaul of the continuous probability distributions and the uniform distribution discussions on finding the mean and standard deviation, finding areas, and then finding x values given percentiles or quartiles. All right, I hope that helps. Good luck.